Now, today I'm going to explain Bernoulli ordinary differential equation. Bernoulli ordinary differential equation is a non-linear first order differential equation. And how do we solve question related to Bernoulli? All we need to do is to convert this non-linear first order differential equation to a linear first order differential equation. And how do we go about that? Now, look at this example on the board. Or let me say, look at this illustration of a non-linear first order differential equation. We have the y dx plus p of x y to be equal to q of x y raised to power n. Now, if you look at this and you relate it to a linear first order differential equation, the only difference there is our y raised to power n. So, in this case, the first step we are going to do if you are given non-linear first order differential equation is to divide full by the coefficient of q of x. Now, let's divide full by y raised to power n. Let me call this equation 1. If you divide full by y raised to power n, we are going to have y raised to power minus n, our dy dx, plus p of x to be y 1 minus n to be equal to q of x. I hope you understand what I did here. I divide full by y all over n. So dividing this by y all over n, we are going to have y raised to power minus n, because y raised to power minus n is the same thing as 1 all over yn. And in this case, we have y raised to power 1. So it will be 1 minus what? The n. So that's what we have there. Now, having said that, we have this. The next step is to let v to be equal to y raised to power 1 minus n. We always represent a single variable like v. You can use any other value. You can use w or z. So, but I assume my v to be equal to y raised to power minus. I'm using this as an instance. Now, in that case, let's differentiate v with respect to s. So, our dv ds will be equal to 1 minus n y 1 minus n minus 1 dot dy ds, because this is what? An implicit function. So we have this. At the end of the day, our dv ds will be equal to 1 minus n y minus n, because 1 minus 1 will be 0, so we are left with minus n, our dy ds. If you look, let me call this equation 2. If you look at this very well, we have our dy ds here, we have dy ds here. The only value, no, I'm sorry, let me call this equation 2, and let me call this equation 3. If you look at equation 2 very well, it is similar to this, because we have our y raised to power minus n dy ds, and we have y raised to power minus n dy ds. So all we need to do is to make our substitution. If you look at this, we can rewrite this. Let me call this 4. That means let equation 4 be, so we divide all the side by this, by 1 minus n, so that we'll be left with y raised to power minus n dy ds. So we have 1 all over 1 minus n dv ds to be equal to y raised to power minus n dy ds. Now, looking at this, I'll call this 5. Our equation 5 can be substituted into equation 2. So instead of writing y raised to power minus n dy ds, we can write it as this. So we have, so putting equation 5 and our equation 3 in equation 2. In equation 2, we are going to have 1 all over 1 minus n dv ds plus, instead of writing y raised to power 1 minus n, we can write it as v. So we have our v to be, let me put put it like this: P of X V to be equal to our Q of X. Now, so this is now linear. It is linear because there is no coefficient of y raised to power n beside Q of S. So this is linear equation. Are you getting my point? So this is linear equation. After getting this as a linear equation, then we can now determine our integrating factor and follow the procedure of a linear first order differential equation. Then we get the value of our y. In the next example, I'll solve 2 or more examples related to Bernoulli equation. Then you get the explanation of what I meant by this derivation in a simplest form. Thank you. This is an example on Bernoulli equation. So this differential equation on the board is what? Is non-linear. So how do we convert this to a linear first order differential equation? So you follow the procedure here, and I will explain in details. Now, we have this equation. The first thing we are going to do is to divide through by what? By y squared. And if we are doing that, we are going to have y raised to power minus 2 dy ds plus we have 1 over s dot y raised to power minus 2 to be equal to s. So I divide through by y squared. Let me put it there. Divide through by y squared. So I divide all the sides by y squared. So we have y raised to power minus 2 dy ds plus 1 all over, this is 1 over s, 1 all over s. From the law of indices, we have y1 minus 2. That will give us y raised to power minus 1. So we have y raised to power minus 1 to be equal to s. So let me call this equation 1. So after getting this, then we can now assume let v be equal to y raised to power minus 1. This is an assumption. We are assuming v to be equal to y raised to power minus 1. So let's differentiate this. If we differentiate this, we have our dv ds to be equal to, if we differentiate y raised to power minus 1, we are going to have minus y raised to power minus 1 dy ds. And my dv ds will be equal to minus y raised to power minus 2 dy ds. Let me call this equation 2. Now, if you look at equation 2, equation 2 is, it has been simplified in such a way that we can denote the whole of this y raised to power minus 2 dy ds as dv ds. But because of this negative sign, we can multiply both sides by let's multiply both sides by minus 1. So this negative will be eradicated. At the end of the day, we have minus dv ds to be equal to y raised to power minus 2 dy ds. So let me call this my equation 2 Roman figure 1. Then we can make our substitution. Now, instead of writing y raised to power minus 2 dy ds, we can write minus dv ds in a simplified form. Minus dv ds. So instead of writing my y raised to power minus 1, we can write it as what? V. So we have plus v, we have s here, so we have v all over s. Yes, the whole of this is v, so it's v all over s to be equal to s. This is now what? This is a linear, first order linear differential equation. But I can decide to remove the negative here by multiplying through by minus 1. Then we have the v, the s, minus v all over s to be equal to minus s. So what's our p of s here? Our p of s will be equal to minus 1 over s. And my q of s will be equal to minus s. Any question? What I did here is to simplify a non-linear equation to what? To a linear differential equation. I determine my p of x to be minus 1 over s. The reason why I got negative here and negative here is because I multiply everything by minus 1. So this will be dv ds minus v over s minus s. So we have this. Then we know the next step. The next step is to determine our integrating factor. Our integrating factor IF will be equal to what? The exponential of what? The integral of p of x, which is equal to minus 1 all over s ds. So this will be minus ln x, which will later give us what? You know, for this is a logarithm. The negative will come as a power. Then we have x raised to power minus 1. This will be eliminated, and we have x raised to power minus 1, or 1 all over s. So our integrating factor is 1 over s. Now, if our integrating factor is 1 over s, then we can easily write our equation. So our integrating factor is 1 all over s. Then we continue by writing it in this form. Y dot integrating factor to be equal to integral q of x dot integrating factor all plus c. Our integrating factor is 1 over s. In this case now it will be v, because we've denoted the value to be v. It will be v to be equal to the integral. What's our q of s? From the question, our q of s is minus s. We have minus s, and our integrating factor is 1 over s as well, all plus c. All plus c. So v over s will be equal to the integral of minus the s, all plus c. Let me check this very well. 1 over s, I'm sure it's 1 over s. So if we have 1 over s here, then we bring them together. So we have this. So our v all over s will be equal to the integral of the s is still s, all plus c. So v will be equal to, we multiply everything by s to make v the subject of the formula. We have v to be equal to minus x squared plus cs. But we said let v be equal to y raised to power minus 1. We assume v to be equal to y raised to power minus 1. So anywhere we see v, we put y raised to power minus 1. So our v here will be y raised to power minus 1 to be equal to minus s squared plus cs. So this is 1 over y to be equal to minus x squared plus cs. So y will be the reciprocal of all this. So we have 1 all over minus s squared plus cs. So that's how to solve Bernoulli equation. Bernoulli equation is similar to first order differential equation. The only difference between them is a Bernoulli equation is non-linear, and you need to convert it to what? To linear equation before you can use the procedure of first order linear differential equation to solve them. Thank you very much. If you have any question related to differential equation, linear equation, Bernoulli equation, homogeneous equation, variable separable, and all form of question under differential equation, please forward your question to the comment section and I'll solve it, and you see how the procedure goes. Thank you. Meet you in the